So if you've processed drone imagery, there's kind of a common workflow that people are familiar with, and it's usually involves collecting a volume of imagery, and now you've got hundreds or maybe even thousands of images that need to be put together in some way so they can be analyzed. And typically what's done is you run this through an orthomosaicing or an image stitching tool to create a map of the field, and then you run your analysis. Well, there's problems, as it turns out, with that particular workflow that cause lots of problems, specifically if you want to do any statistical analysis on your data, and I want to point that out here. So if you haven't done this before, I recommend you do it. It's enlightening, really. So this is, again, a near-infrared image of relatively early season corn. What I'm going to do is just highlight a zoomed-in portion of this orthomosaic. And it may be difficult to see, but what I'm going to do is identify some areas of this image. Within these orange boxes, you'll see some strange things going on in the imagery. So within this circle here, you'll see there's kind of an odd circular feature in this image. You'll see there's a weird kind of blob structure running up and down through this image. And what these are artifacts of the orthomosaicing or the image stitching process. And it's important to realize that image stitching software was developed to create panoramas, really for photography purposes. And these little features, you know, when you zoom out, you don't see them, and it looks like a pleasing image. But that's not our purpose here. Our purpose here is to run analysis and computations on imagery. And it's these little artifacts that are introduced by image stitching that cause a lot of problems on the accuracy of your information. So again, the traditional method has been calibrate your images, aggregate them into a map using an image stitching software, and then run your algorithms to extract your statistics. Well, to avoid this process, we came up with a new method, which basically said, let's calibrate the images, let's extract the statistics from the images before they've been assembled into some sort of map, and then let's aggregate the statistics as opposed to the imagery. So we're kind of inverting the order of operations in the software here to completely avoid having to run analysis on an orthomosaic. And if you've had problems with the accuracy of stand counts, if you've had problems with accuracy even on some of your stress measurements and things like that, this can explain a lot of the reason why. Is, you know, you're analyzing portions of an orthomosaic that aren't real information. It's kind of been put in there by an algorithm to be visually pleasing when zoomed out. One key point to make, though, is that orthomosaics have their place and their value, and particularly for human interpretability of information. And you'll see orthomosaics throughout our data samples today, but we create those purely on their own processing pipeline just for human interpretability. All the statistics we develop are based on a separate processing pipeline that doesn't involve the orthomosaic.